Hi everyone, hope you're doing well. Okay, so we're going to carry on and we're going to apply the idea of radians. I'm going to show you just one example of when it's quite useful to use radians, and there's a lot more, and especially in calculus it becomes essential to use radians instead of degrees. But here's one example that you need to know about, and it's arc length and area of sector. So a quick recap from GCSE: if you have a circle, let's imagine we're using degrees, and we have an angle, theta. Should we call it theta? Theta degrees. Two things that you need to work out sometimes is the length of the arc and the area of the sector. So I think hopefully you've seen this before. Let's just quickly recap these. So to get the arc length, what you'd have to do is find, let's say that there's the radius here, call it r. What you'd need to do is to find the whole circumference, which would be 2 pi r, and then you'd need to multiply by the fraction of the circle that you've got. So in our case it's very general, we've got theta out of the whole circle, which is 360. And that will give us the length of the arc. And I guess we could simplify that down. It would become pi r. The 2 would cancel with 360 to give 180. Like that. Okay, and that will give you the arc length. And the area of the sector, we do the same thing. We calculate the area of the whole circle, which, if you remember, the area of a circle is pi r squared. And then we multiply by the fraction of the circle that we have, which is again theta out of 360. Theta out of 360. So in this case, it would sort of combine together to say theta pi r squared over 360, and that would be our formula, GCSE formula for the area of the sector. So hopefully that's familiar. Now notice that these formulas are a little bit unwieldy. Let's see what happens if we use radians instead. So let's do the same thing. Circle, an angle, but this time we'll do it in radians. So here we've got r again, and let's do the same thing. So we calculate the total circumference of the circle, which is 2 pi r. Sorry, let me just slow down. We're doing arc length. So the arc length, it would be the whole circumference, 2 pi r, times the fraction that we've got. Now this time, because we're using radians, the fraction is theta out of, remember what's the whole circle? We said it was 2 pi radians, not 360 degrees, 2 pi radians because we're working in radians. Now the nice thing about this, using radians, is can you see what it's going to be? We're going to be able to cancel a big chunk of this equation. So we're going to be left with just simply r times theta. And that's going to give us the arc length. As long as theta's in radians, we've got a really neat little formula. So let me just write this, arc length. So you'll definitely want to write this down because this is the formula for arc length. Can you see how it's much nicer than pi r over 180, which was the degrees version? The radians version is simply radius times angle, gives you the length. And that's because of the way radians are. This is the way that they are sort of structured. Let's do the area of sector. Now we do similar to what we did before. We take the whole area, pi r squared, that's the whole area of the circle. We times it by the fraction that we've got, which is theta, divided by the whole circle. Now, a whole circle in radians, do you remember what that is? It's 2 pi radians. It's not 360 degrees, it's 2 pi radians. And you see again, we can have a cancellation here, and if you sort of simplify that and sort of juggle it slightly, you end up with this half, which is the same thing as divide by 2 r squared theta, and that's the official formula for area of sector in radians. So just a reminder, these two formulas will only work in radians. So let's just write that down. But in your exam question, very important to remember that. But we only ever use radians when we do this type of question. So we never ever use these anymore. So don't use degrees. Never use these. Only use the radian version, because that's what's gonna come up in your exam. So only use radians from now on. So, quick example could be, here's a circle. Let's say we've got a radius of 12 centimeters, and we've got a angle of, shall we say, pi over 3 radians. Question might be, calculate the arc length and calculate the area of the sector. So it's very simple. If we look back at the formula we worked out here, the arc length is r times theta. So we simply do radius times theta, which is the angle, pi over 3. 12 over 3 is just 4, so it's 4 pi centimeters. 4 pi centimeters, you might think that sounds a bit obscure, so we can calculate the decimal, 12.6 centimeters. In the exam I would do both, personally. 12.6 centimeters is this arc length here. So it's very easy to use. Now let's do the area of the sector. So we need to go back, find our formula. Area of sector, half r squared theta. Half r squared theta. So half times r squared, which is 12, in a bracket, theta, pi over 3, type it in. If you're lazy, use the calculator. 12 squared, divide by 2, times fraction pi over 3, 24 pi. 24 pi is the area. As a decimal, 75.4. So that is how you work out arc length and area of sector using radians. So just a reminder, from now on we're going to use radians every time we do this type of question. So that's hopefully an introduction to doing that, and I will see if I can get you some questions to try. Okay, thanks guys, see you later.